Welcome back to another Learn PowerShell video. Today we're going to exponentially speed things up and talk about loops like for each, while, and do while. We'll also go over some terminating statements like if else and try catch. These are fundamentals to scripting and basic building blocks, so before we start diving into script writing and building our own tools, we need to have a more moderate grasp on the way each of these work and how we can utilize them. First, we'll start with for and for each. These are closely related. Let me start by saying they operate almost identically. So if one makes more sense to you, just stick with it. Let's insert a snippet and walk through this. So if you're familiar with a for statement, then what you see here all makes sense. If not, this probably looks like a bit of gibberish, but let's walk through it sequentially. First, we have our statement being defined as a for. And then we have to define our parameters which exist inside these parentheses. We begin by initializing a start point, which here is I equals 0. And you will commonly see in a for loop it being called I. That is because this is the initialization point, so it's just become common practice to be I. Next, we have the portion that says how we're going to iterate through this loop until a condition is met. In this case, the condition is as long as the total count of the imaginary array, which we haven't actually established, is less than the total count of the entire array. We can establish an array in a moment, but I'm going to finish walking you guys through this. And finally, we tell it how we're iterating through the loop. So we're incrementing I here in an ascending manner. So I++ tells PowerShell that we're going to add 1 to I every time we loop through. So if I go through this, I'm actually going to print I so you guys can see how I runs. So you guys can see that I stops at 99. You guys didn't see this, but I will show you. My array is up to 100, so I have an array that looks like this, 1 through 100, and that is just telling PowerShell that as long as I is less than the total count of the array, which is 100 items, then we're going to keep doing this. And the array ends at 100, so less than is 99, and that's when we stop. Nothing crazy. If I change this to 101 and I print the array entry for that wherever we are in I, you'll see that it changes the output a little bit all the way to 100. So we know that as long as I is less than 101, it's going to run, and the last count number in the array is 100, so we're going to print all of those. So I don't typically use for statements because my brain prefers more plainly worded scripting. So let's move on to the for each statement. So I'll insert a for each. I should not have highlighted that. Delete this first. So after inserting the for each snippet, you can just plainly read what's going on here. The structure is the same, but there are some key differences, at least in readability. A for each statement by default steps through every object in the group. It doesn't matter how many are there. It doesn't need you to count or tell it. We don't have to tell it to stop because it's just going to run into completion. And we also don't have to give it a starting point because it starts at the very first item in the collection. We can tweak this to start halfway or even run it against a single item in the collection, which I frequently do for testing, but we're not going to do that now. So all you have here is for each item in a collection, do something. So if we make the collection, let's just say 1 through 25, and print that item that it's on, you will see that it prints 1 through 25. So what's going on here is item is now the variable for every single iteration, whereas we don't have that luxury with for. With for, you actually have to tell it where it's supposed to be or things like that. So it is a little harder to use for when you're doing things like this because you have to actually index items. Here you don't have to do that. You can just have it index wherever it is um, in the group of the collection. There is another way to do it for each, and that's with a pipeline. So if uh, I'll leave collection up so you guys can see it. So you can pipe and you can say for each object, and then another script block the same way. You don't actually have to say for each item in the collection because it automatically understands that this is the collection. And the item we're going to be working with is actually a different variable. So we actually don't have to define the item variable. We just say $sign underscore, which tells it to go ahead and do exactly what we did before. Um, this is a simpler way to write it. However, your usability kind of tracks a little bit when you're trying to write complex, long flowing scripts. This is really good for single line statements though. This way, $sign underscore is kind of a difficult variable to understand, but it just says whatever item in the iteration, and $sign underscore only works after the pipeline. So I don't want you guys thinking you can use this anywhere else other than after this pipeline. All right, so now let's move on to while and do while. So these are probably dangerous to use without a clear understanding because you can get stuck in these loops unintentionally or intentionally, as I've done with purpose. Here you tell PowerShell how to keep doing something until some manual condition is met. So let's insert a while snippet and see how plain it is. So, I mean, this looks simple enough, right? So let's make a condition that runs while I is not equal to 100. So and have the script, I guess, add 2 each time. So say I equal or plus equals 2. And let's initialize I at 0 and see how this runs. It's actually also print I so you guys can see where the stopping point is. So you guys can see here that every increment is by 2, and then it stops at 100, exactly where it's supposed to stop. As I mentioned, you can unintentionally get stuck in these loops if you don't have a very clear defined stopping point. So if I increment by 3, as you guys all know, 3 plus anything starting from 0 is never going to equal 100 because it's 99 and then it skips to 102. So if I do this again, it's going to infinitely print numbers and never stop until my computer runs out of memory or it just shuts off for some other reason. So do while almost runs the exact same way. So you do something until a condition is met. So this isn't supposed to be here. I need to stop highlighting and putting things in. So this is a do while statement. So you are doing something while the condition is met or not met, whatever it is. It's almost the flip of a while statement. And that's the best way to explain it because the while statement checks the condition before it runs, and the do while statement checks it after it runs. So if you remember those, you probably will figure out when you should or shouldn't use the opposing statement, when to check. It's going to be one or the other. There really shouldn't be anything in between. I guess it's really just kind of the code you have built around this statement that defines when you should check this statement. All right. So moving on to terminating statements, if you've ever seen a flow chart, um, then you're probably familiar with the visual representation for an if-else statement. You can run an if statement by itself, just the if portion, like this. However, where this gains some of its robustness is with the addition of else if and else. So what this is saying, if you can imagine a flow chart, is saying it's going to check this statement. And if this evaluates to true, whether it be, is the sky blue? It'll run this part. If it evaluates to false, it's going to keep moving down the line. So consider everything after this as the no part of the flowchart. So then it's going to check this statement and process it exactly as it processed the if statement. So it's going to say, is this true? And if it's not, it's going to keep moving down the line. If it is, it's going to run whatever code we have here. And lastly, it's going to do this if none of the above conditions evaluated to true. So an easy way for us to look at this is actually, I guess, kind of using some colors. So let's go ahead and do this. I pre-wrote this colors array. So we have these colors: blue, red, green, yellow, magenta, cyan, green. So let's say that we're going to randomly select these colors. And that's supposed to be a pipeline. And before we do the if-else statement, I want to add in this chooser so you can see which color it's selected. So what that's going to look like, if I run this a couple times, you'll see that the first color it's selected is blue, the second color it's selected is cyan, third one is yellow, and it's changing the color to match the word because RightHost has this color coded ability to it. So now let's write an if statement that tells us, I guess, if we have a primary color or not. So for the condition, let's say if selection equals red, then we will say the primary color you've selected is, and whatever the selection color is. Let's add a period here for proper grammar. Now let's just copy this a couple of times, not the if portion, and let's write an else if. Let's delete this brackets, change red to blue, and add another else if, and change red here to green. And then let's add an else to close off the rest of the colors because red, blue, and green, I think, are the primary colors. If it's any one of these four, then we're going to say that it's not a primary color. So let's say your random selection was not a primary color. So now if we run all this all over again, our color happened to be magenta, and we got back that your random selection was not a primary color because we know that magenta is not red, it is not blue, it is not green. So by default, it has to come down here to say your random selection was not a primary color. If I try to run this again, cyan, same thing, magenta, green. So here we go, the primary color you've selected is green. So there's not a whole lot going on here that isn't plain to read, but you can see the way we can set terms to operate in. And this is not the ideal way to script even something as simple as this, but this is the easiest way to see it, learn it, and understand it. We can work on minimizing our time complexity and using advanced commands in later videos. So lastly, we have try and catch. So this statement is super vanilla on the surface in that it does exactly what you probably think it does before I even write this. But it can be really advanced. We're not going to go into that though, because it can get way beyond what we're ready to in these beginner videos. Error handling, exceptions, things like that. So we can just do try 1 + 1, and If that doesn't work, that didn't work. So obviously we expect 1 plus 1 to work perfectly fine and evaluate to 2. If though we did something that didn't work, like let's try get child item, let's just say see foo bar. I know that doesn't exist on my computer. I expect it to throw an error. Because I'm not actually defining the error, it's not going to give me this. I just need to have something in the catch block. I can tell it to actually output this error specifically, or I can save this error, or I can save whatever iteration if I do a try catch block inside of a loop. Whatever I'm doing, I can alter that here in this catch because this catch will then allow me to do something if it didn't work. Rather than just halting altogether and breaking, it will just attempt to do something. If that doesn't work, it'll give me an error and I can do something with that later. So that's a wrap on this session. Thank you for watching. We'll have a new video soon where we're going into writing our own scripts. So it is going to be quite a bit further than we are now. However, I don't want you to get overwhelmed. So we're going to take it very slowly and start with some basic things in very plain, understandable ways. All right. Thank you, and I will see you soon.